Welcome to the section on polynomial equations and factoring. In this section, we're going to be looking at the introduction to zero products, and sometimes it's helpful to see why we need to know this. And so this first page is just an introduction. If you want to read it yourself, you can go ahead and skip this video. When working on your mathematical mindset, it will always be helpful to try and make things easier to calculate. This will be true throughout this class, but even more obvious when you get to calculus. One way to make polynomials valuable is to find when they are equal to zero. This usually happens when we want to know when a polynomial equals a certain number. Then, through a process of rearranging the equation, we have a quadratic set equal to zero, and here's an example of such a situation. A quadratic function p of t models the percentage of nuclear plants in operation in 1970. Now remember, this is when t equals 0. And here's this equation we have here. P of t equals 0.027t squared plus 0.216t plus 53.3. This can be derived by using regression models. If we wanted to find the year for which the percentage of nuclear power plants were operating at 85% capacity, we would change our function into an equation because we want to know when P of t equals 85. So we would set our function P of t equal to 85, but this is not easy to calculate. So we use a method called the zero product method to make it much easier to calculate. We take that 85 and we subtract it from both sides. We call that setting the equation equal to 0. And by doing this, we could then find the two values for which time would give a percentage equal to 85. And you can see that process here. I set it equal to 0, and now we have this equation equal to 0. Notice that we could use a graph or the quadratic formula to solve for the time for which we are curious. This is why we are learning about zero products. And then we'll use that information to be able to apply it to all sorts of polynomial functions like I showed you above. So before I let you go, I want to connect it to the theoretical ideas behind zeros of a polynomial. If you have a zero equal to some product of variables, then we know that either the first factor or the second factor has to at some point equal 0, or it won't make any sense. So if a times b equals 0, then a has to equal 0 or b has to equal 0. There's no other way around it. If a equals 0 or b equals 0, then a times b will equal 0. And this will be true for all these different concepts about factoring. So the principle of zero products in solving polynomial equations is as follows. Write an equivalent equation with 0 on one side using the addition principle, like I showed you above in an example. Factor the non-zero side of the equation. This idea of factoring is what we're going to start really looking into over the next few days. And then we set each factor that is not a constant equal to 0 and solve for the resulting equations. This is how we find out what our one or two or many solutions are to a polynomial equal to 0.